Welcome to the next video in the systems programming video series. In this video, we have just finished up the code jam thing. And so I think we are now on to assignment number 8. And so in assignment number 8, it has us essentially just implement our own custom version of malloc. So we're going to understand malloc much more deeply than perhaps we did before. So the step 1, I think mostly does not concern us. Step 2, code setup, your base code. So over here we have the assignment number 8 with all of this base code. And so we've got these benchmark files, rand for randomization, sbrk, so that's sbreak. And I guess we're replacing the standard sbrk with one that's based on mmap. Not totally sure why. I think I have maybe heard that it's better, but I don't know. Anyway, and then there's this malloc. So that's where we're going to implement our own custom malloc function. We're going to use a first fit strategy. We'll talk more about what that means in a bit. And then there's this node. This assignment is based on the reading, blah, and you should complete the reading and finish the implementation of malloc.list.c before starting the assignment. So I went to this, I think you can just Google this and find this. But I found it very hard to parse through. I'm sure it was sort of distributed and presented in the context of a course, and so lacking that course, I found it very hard, or even lacking the presentation, I found it very hard to make sense of what it was saying. So I'm not going to really think about or mess with that directly, and instead I am just going to try to implement the my malloc sort of function as best as I can understand how to do that. I think it came out correctly. So we come over here, we're in the malloc list.file. There's a whole bunch of includes. This struct chunk is supposed to, if this was distributed with the base code, so I didn't create this. But just to explain what it is supposed to do or represent, and actually, I think I did add this char free, and char is like, it doesn't really need to be a char, but I just made it the smallest possible data. I just want to set it to either 0 or 1. That's the whole point of this char, is just so that it can be 0 or 1, indicating whether a block of memory is free or not free. So when you initialize it, it is initialized to not free, but when you free it later on, it is set to 1, right? This char free is set to 1 to indicate that this whole block of data is now free. The chunk also has a size parameter telling you how big the block of data is, and it has a pointer to the next chunk of data, basically. Now, the heap memory for a program is going to then essentially be a linked list of these chunks. And initially, when a program starts running, that linked list is empty, and the sort of signal for this linked list being empty is that its pointer is null. And this is, again, distributed by the course, and so I did not create that. Now, there are these helper functions that, and so I'm basically going to let you see the code, but try to sort of describe what came with it and what didn't. So I wrote this function. We'll talk about this more later. I wrote this function. I think, if I'm remembering correctly, I can sometimes forget what I did and what was already here. And then there's this malloc, which the function declaration and some amount of the internals already existed, but I heavily rewrote what was on the inside. And I think what was on the inside was maybe like a very basic implementation of a malloc function, but it was so basic that I don't think it was the intended kind of way that even a basic malloc function is supposed to run. So I heavily rewrote the inside of the malloc function. Free initially did nothing at all. So although the function declaration was here with the code distributed by the course, I implemented everything inside. And then I have not yet implemented frag stats because I basically wanted to just talk through what I've done here before I forget what I did. So I just want to talk through and describe this before getting on to the other topics. Now, so that's just a brief description of what code was distributed, what the assignment is, and what parts of this I have already implemented. So the next thing to talk about is what are we even trying to do? What does a malloc do in the first place? Well, for one thing, it tries to create a bit of memory reserved for some variable. So each chunk here is supposed to be the memory reserved for some variable or represent important information about it. And so when you malloc, you essentially need to check to see whether or not there already exists some amount of free space in your heap memory that is big enough to accommodate the malloc, right? So you want to check to see what you already have and whether what you already have is big enough to accommodate what you're trying to do. That's the first thing that a malloc should do, in a sense. But then, what if there isn't the space that you need, right? What if you are trying to malloc more than what your current allotment of heap memory would allow? Well, then you need to request extra space from the operating system. And so, that kind of is a quick description of why I wrote this function, request space. So you want to be able to find a free chunk, right? For the given data that you already have, and you're trying to, or malloc, I don't think I said that exactly right, but basically you want to malloc a certain amount of space. And the first thing that you want to do is check to see whether or not that space is already available in the heap memory that you've already been allotted. And if it is, then you just put it there. So finding a free chunk is its own pretty sensible component of this whole thing, and that's why I abstracted it into a function here. But if you can't find a free chunk that can fit the space that you need, then you want to request from the operating system extra space, and then perform the malloc from there, basically. So that's the main idea. That's the big picture. And so I think maybe that's enough of a high-level description that I'm going to end the video here just before getting into any code, because this is going to take a while. So maybe now that I've described the assignment, described what was given, described what you maybe want to be thinking about the tasks that the program is supposed to do when malloc is called, then having described all of that, the actual implementation can come in the next video.